this problem, they have said that alpha, beta, gamma, del, and so on be the roots of the equation fx equals to 0. And Sm is the sum of the mth power of the roots. Okay, then prove that f dash x by fx equals to sigma m starts from 1 to infinity Sm minus 1 x to the power minus m for all x greater than the maximum value of the roots. Okay, now first let us understand what is Sm. Sm is basically the sum of the mth power of the roots. So what is S0? S0 is the sum of the roots to the power 0. That is alpha to the power 0 plus beta to the power 0 plus gamma to the power 0 plus del to the power 0 and so on. Is it clear? What is S1? S1 is basically the sum of the roots to the power 1. Okay. What is S2? S2 is the sum of the square of the roots. Is this clear to all of you? And so on. And so on. Okay. Now, say fx is a polynomial having the roots alpha, beta, gamma, and del. So, I can write fx as a times x minus alpha, x minus beta, x minus gamma, x minus del, and so on. Okay. So, if I take log on both sides, so we are getting ln a plus ln x minus alpha plus ln x minus beta plus ln x minus gamma plus ln x minus del and so on. Okay. Why I have said that here in the condition they have said that x is greater than max of the given roots. Now you can understand why it has been given, because you see, if x is not greater than the maximum value of the roots, then one value inside log will become 0 or less than 0. Is it clear? Is this clear? Now to define that log, we have said that x is always greater than the maximum of the given roots. In that case, all the logs are very much defined. Is it clear? Differentiate both sides with respect to x. So what we are getting? F dash x by fx is equals to 1 by x minus alpha, 1 by x minus beta, x minus gamma, x minus del, and so on. Is it clear? So which says it is nothing but your x minus alpha whole to the power minus 1, x minus beta whole to the power minus 1, x minus gamma whole to the power minus 1, x minus del whole to the power minus 1, and so on. Now, if I take x common from each term, then we are going to get 1 by x, 1 minus alpha by x to the power minus 1, 1 minus beta by x whole to the power minus 1, 1 minus gamma by x whole to the power minus 1, 1 minus del by x whole to the power minus 1, and so on, right? Now, you observe carefully that we all know that the expansion of 1 minus x to the power minus 1 is basically 1 plus x square plus dot dot dot. Okay, this goes till infinity. Okay, now if I expand those terms individually, then what we are going to get, first thing, remember it, see this thing carefully, the first term of every expression will be 1. Here from the first term we will get 1, from the second you will get 1, from the third you will get 1, and so on. So it is basically, we can write this thing as alpha to the power 0, because alpha to the power 0 is 1, then beta to the power 0, then gamma to the power 0, then del to the power 0, and so on. So this thing can be written as S0 directly. Have you understood this? Why? Because as I told you, S0 is nothing but the sum of the given roots to the power 0. Is it clear? Next, if I expand the thing, the next term that we are going to get is alpha by x. From the second expression, we are going to get beta by x. From the third expression, we are going to get gamma by x, and so on. So if I take 1 by x common, we are going to get alpha plus beta plus gamma plus del and so on. So which is nothing but your S1. Similarly, the third term will be 1 by x square, alpha square plus beta square plus gamma square and so on. So it is nothing but your S2. Then the next term will be S3 and this thing goes on. Is this clear? Now this can also be written as, look at carefully, 1 by x S0. If I multiply with 1 by x, we are going to get 1 by x square S1, 1 by x cube S2, 1 by x to the power 4 S3, and this thing goes on. So let me write it in the sigma way. So it's sigma m equals to 1 to infinity. I can write S m minus 1 x to the power minus m. Yes or no? Because in place of m, if I put 1, so first term that you are getting is S0 x to the power minus 1, that is 1 by x. Exactly the same term you got in the first. In the second term, you will get, if I put m equals to 2, it will be S1 x to the power minus 2. Exactly the same term you got, and so on so forth. Okay? Hence, proved. Have you understood this problem clearly?